Yes. Hey. So yeah, I made one. So I guess you just put some ball bearings in here, which are the 6 millimeter airsoft pellets. So you line it with that, and then you place this on top, and then it creates a turnable surface. So you get multiple together, and one turns the other. It's obviously not turning very well right now. I need those balls. Uh, yeah, which is going to be really badass. They're printing the base, a second base, and then maybe print the inside. And then there's another one. So we're probably going to do like 6 of these things to fill up our space. I think it's going to look really badass. But yeah. But I put a mount. I think I might change it up. Got the Raspberry Pi down here. Still need to do cable management. There's another mount that sits right here, and so it aims like this instead of like this. And this one kind of sucks. Is the autofocus. You kind of want it like right here, not right here, because then it autofocuses out here. Looks really bad. So I might print another mount. This one's not working out too well. Which is kind of cool, so you can go through like an iterative approach to how exactly you want things. And most of the shit, most of these gears and whatnot, these are just a setting in Fusion 360, and you just put a ratio down of the two surfaces, and it automatically calculates how many teeth you need, and you know, depending on how big based on the radius, it gives you, you know, a different diameter, right? But it properly calculates all the teeth that you would need, which is not an easy calculation, actually. I'm not a mechanical engineer, so I didn't go to school to learn that stuff. But you don't really need to know it. I mean, I guess you do need to know it if you're going to program something like that up, or even make them by hand, I suppose. But I mean, there's many tools to get some of these high-level concepts right in our own homes without much know-all, which is honestly I mean, we compartmentalize information and then use that compartmentalized information to make better and better things. So you know, it's kind of cool that we have the ability to abstract away that problem of trying to make gears. Because this is not easy. This is not easy to do by hand at all. This is what 3D printers are for gears and small, very, very complicated things, and things that need to be meshed together with other things that you just can't get from woodworking or whatever. I mean, you can always use a CNC and a router, but I mean, you're not going to get a fine. Well, you can get fine detail with those as well. I guess you can always use a router for most things. But what this allows you to do, and this is not a good example of it, is that it lays it layer by layer. So you can print moving parts within moving parts. Like, I haven't done one yet, but you can totally make things without hinges that just move because they're printed together. And what they call it, I think it's called like compliant engineer, or there's a name for this, where things like move a certain way so that they don't break, but so it allows it to operate at a lot more times than what it normally would if you put it in a different kind of mechanism. So just allowing things to move and bend just a slight bit over time allows a compliant mechanism to really outshine a lot of different other applications or different other, you know, shit. I guess I'm running out of words to express these ideas. A lot of the Mars rover was built with certain plastics that were compliant we're very compliant. I don't even know if this is the right word. Maybe I shouldn't be using it. But basically, they bend so that they don't break, but they bend just enough to allow them to achieve a functionality that normally you wouldn't have gotten from that. And I mean, if you think about it, even your fingers themselves are compliant. As you press down on the surface, your finger actually molds to the surface. So I mean, you can't just create a plastic finger that is going to have the same kind of capabilities as your finger itself, just because of the touching. I mean, it's compliant. We're compliant. Everything that we do is we mold ourselves to it. So I mean, you can get that also with 3D printed parts. I just don't have an example, but yeah.